Welcome to Innovation Explorers. Experience the captivating realm of innovation, design, science, and technology. What is 3D printing? In manufacturing, 3D printing refers to any of a number of techniques for producing three-dimensional items by successively stacking two-dimensional cross-sections one on top of the other. Although the technique is referred to as printing, it actually involves binding or solidifying a liquid or powder at each location in the horizontal cross-section where solid material is wanted. The procedure is akin to the fusing of ink or toner onto paper in a printer, thus the word printing. When using 3D printing, the layering is carried out hundreds or thousands of times until the product is complete in every vertical dimension. 3D printing is frequently used to create plastic or metal prototypes fast while developing new parts, but it can also be used to create finished goods that can be sold to customers. From plastic figurines and mold designs to steel machine parts and titanium surgical implants, 3D printed items come in a variety of materials. A cabinet the size of a large kitchen stove or refrigerator may house an entire 3D printing setup. The phrase 3D printing initially referred to a particular procedure known as 3DP that was developed by Massachusetts Institute of Technology, MIT, researchers in 1993 and licensed to several manufacturers. The phrase is now used to refer to a variety of connected operations generally. Computer-aided design, or CAD, is the foundation of all of them. Engineers create a three-dimensional computer model of the product to be constructed using CAD software. This model is converted into a succession of two-dimensional slices of the object, after which the printer is given instructions that specify precisely where to harden the initial material on each new slice. Most procedures begin with a fine metal or plastic powder as the raw material. The powder is typically kept in cartridges or beds from which it is dispersed in tiny amounts and spread by a roller or blade into an incredibly thin layer, typically only the thickness of the powder grains, which can be as small as 20 micrometers or 0.0008 inches, over the bed where the part is being built up. A device resembling an inkjet printer head passes across this layer in the MIT 3DP process. A binding agent is sprayed using a series of nozzles in a pattern that is predetermined by the computer program. After that, a new coating of powder is applied to the entire build-up region, and the procedure is repeated. The build-up bed is precisely decreased by the thickness of the fresh layer of powder at each repeat. The built-up component, which was previously embedded in unconsolidated powder, is removed once the process is finished, cleaned, and occasionally subjected to additional post-processing finishing procedures. Early iterations of the 3DP method mostly produced crude mock-ups composed of plastic, ceramic, and even plaster, but later modifications also used metal powder and created more precise and long-lasting parts. Selective laser sintering, SLS, is a comparable procedure in which the nozzle head and liquid binder are swapped out for precisely guided lasers that heat the powder and cause it to sinter, or partially melt and fuse, in the desired locations. SLS typically uses either plastic powder or a metal binder powder mixture. In the latter instance, the constructed object may need to be heated in a furnace for additional solidification before being machined and polished. Direct metal laser sintering, DMLS, which employs a high-power laser to fuse a fine metal powder into a more solid and completed object without the need of a binder substance, can reduce the need for these post-processing stages. Another alternative is electron beam melting, EBM, in which an electron cannon is used in place of the laser system to focus a strong electrically charged beam onto the powder under vacuum. Advanced steel, titanium, and cobalt chromium alloys can be used as final products in the most advanced DMLS and EBM procedures. The 3DP, SLS, DMLS, and EBM building up principle is used by a wide variety of different procedures. So that the item is not submerged in the substance, some people utilize nozzle systems to exclusively send the starting material, either powder or liquid, to the appropriate build-up areas. In contrast, a thin coating of polymer liquid rather than powder is poured across the construction area in stereolithography, SLA, and the specific part portions are condensed by an ultraviolet laser beam. The assembled plastic component is taken out and placed through post-processing procedures. In contrast to casting or molding an object in a single step, a consolidation process, or cutting and machining it out of a solid block, a subtractive process. All 3D printing techniques are what are known as additive manufacturing, or additive fabrication, processes. As a result, they are thought to have a number of benefits over traditional fabrication, the most notable of which are the lack of the pricey tooling required for foundry and milling procedures, the capacity to quickly make complex, bespoke parts, and the generation of minimal waste. However, they also have a number of drawbacks, such as low production rates, inferior precision and surface polish to machined parts, a relatively constrained selection of materials that can be processed, and severe restrictions on the size of parts that can be produced affordably and without distortion. Due to this, the primary application for 3D printing is in fast prototyping, which is the speedy manufacture of components that will later be mass-produced using conventional manufacturing techniques. However, researchers continue to experiment with 3D printing, creating items as diverse as automotive bodywork, concrete blocks, and edible food products. Commercial 3D printers also continue to advance their techniques and expand the markets for their finished goods. The process of using 3D printing principles to create biological entities, such as tissues and organs, is known as 3D bioprinting. Bioprinting uses bioink, suspensions of living cells and cell growth medium, which may be created in micropipettes or other devices that function as printer cartridges. Bioprinting is largely based on existing printing technologies, such as inkjet or laser printing, but uses these technologies instead of ink. Cells are subsequently distributed in predetermined patterns onto culture plates or other sterile surfaces under computer control. Human embryonic stem cells have been printed in pre-programmed patterns that help the cells aggregate into spheroid forms using valve-based printing, which allows for fine control over cell deposition and improved preservation of cell viability. These 3D printed human tissue models are particularly useful in the field of regenerative medicine,